Very good day to you all, and a warm welcome to pre-webinar on retrofitting hockey turfs to meet international standards, a collaborative effort between Structural Design Institute, most commonly known as SDI, and our esteemed partner, Civil and Structural Engineering Consortium Private Limited. If this is your first time with us, SDI is an educational institution that has a lot in store for you. We specialize in engineering, covering areas such as design, construction, and software training. What sets us apart is our close affiliation with civil and structural engineering consultants, a name synonymous with excellence in the field, having worked on several iconic projects in Sri Lanka. At SDI, we are committed to the continuous professional development of engineers, so we offer CPT courses and events for those pursuing charterships or looking to enhance their skills. You can see a few of our ongoing and upcoming courses here. We are focused on structural analysis and design, architectural modeling, and even some courses focused on specialist topics. What sets us apart from other similar organizations is our exceptional faculty, as our educators are all practicing engineers with extensive real-world experience, some of whom are even renowned in academia. We also offer a set of publications, including tall building guidelines for Sri Lanka and construction specifications for tall buildings in Sri Lanka, as shown on the screen, with more to come. These books encapsulate our team's wealth of experience diving deep to design and construction specifics. Today's webinar, the sixth in our row series for the year, Retrofitting Hockey Turfs to Meet International Standards, focus on the key engineering performance requirements involved in upgrading existing hockey fields to align with global benchmarks. This insightful session will explore the technical, structural, and functional aspects of turf retrofitting, including surface preparation, drainage and basement enhancements, material specifications, and compliance with international sporting standards. It is a valuable opportunity for both aspiring and practicing engineers and professionals in sport infrastructure to broaden their understanding of modern retrofit strategies that improve play, quality, safety, and long-term durability. Before we begin today's webinar, I'd like to go over a few housekeeping points to ensure a smooth and successful session. Firstly, if you have any questions to be directed to the resource person regarding the session, please send all your queries to the YouTube live chat and we will direct them to the resource person for you. All questions in the live chat will be answered during the Q&A session. Secondly, please note that a certificate of participation will be awarded to all attendees who complete the attendance form. The link to this form can be found in the description of the YouTube live video, and we will also be sharing it in the YouTube live chat. Important, the attendance form is not open yet. Let me repeat, the attendance form is not open yet and will not be accessible now. It will only be accessible once we announce it during the webinar. When the time comes, we will post a message in the live chat indicating that the form is open. So please keep an eye on the live chat for that notification. Once the form is open, it will remain available for only 20 minutes. So please make sure to fill it out within the time if you wish to receive your certificate. If you experience any issues while trying to submit the form, kindly take a screenshot of the problem and send it to us via email or WhatsApp. Please note that we will not be able to answer phone calls during the session. So messaging is preferred for any assistance. With that, let's begin today's webinar. It is with great pleasure that I introduce our distinguished speaker for today's webinar, Engineer Kitmal Pereira. Engineer Kitmal is a distinguished professional with extensive experience in structural engineering, construction supervision, and project management in Sri Lanka's building and infrastructure sectors. He holds a BSc Engineering degree and a Masters of Engineering in Structural Engineering from the University of Moratua. He has also completed his MTech in Construction Management at the Open University of Sri Lanka, strengthening his expertise in modern construction methodologies and project delivery. Engineer Kipmar is a chartered engineer of the Institution of Engineers Sri Lanka and a member of the Royal Institute of Chartered Surveyors UK, reflecting his strong professional credentials both locally and internationally. With nearly 2 decades of industry experience, Engineer Kipmar currently serves as the Managing Director of LCMC, the construction management arm of Civil and Structural Engineering Consultants Private Limited. Throughout his career, he has held key positions and contributed to many landmark developments in country. His extensive portfolio includes the Colombo Lotus Tower project, Cinnamon Waterfront project, Colombo City Centre piling works, and many more multiple high-rise residential and commercial developments. With deep expertise in construction management, structural coordination and quality assurance, and large-scale project execution, Engineer Kipmar brings a wealth of practical and technical knowledge to today's session. We are honored to have you, sir, with us and look forward to an insightful discussion powered by your experience in engineering and construction management. Over to you, sir.
Thank you, Andrea, for the long introduction. Today, normally, when we consider the world population, it's around 85% involved in the sports. That means some people are playing, watching, and also supporting for the management level. So that means most of the people they are like they have sports. So this is one of the because I was used to play hockey in my school days and university. So that as that opportunity I got to develop the Colombo and Margaret hockey turf to rectify the proposals and also the design. So this is the content. So I will go pretty fast because I have around 50 slides to cover. So I mean, with the introduction about the hockey turfs and also the turf. There are 2 turfs in Sri Lanka at current condition of that being passed. We already rectified those things and international standard for the hockey turfs. Then how we rectify the hockey turf in Sri Lanka and also lighting requirements. Now common hockey, there are a lot of night matches are played and there are a lot of requirements and also construction considerations, maintenance procedure and also issues and the limitations. So when hockey is the world's third most popular team sport, over 30 million of people are playing. 20 years ago, hockey is well famous in the South Asia and also Asia, but at that time that all the players playing in the grass. But with the technology development and also improvement of the game, so from 90s after mid of 90s that international hockey changed to the synthetic turf hockey, playing on the synthetic turf surfaces. So because of that, lot of playing technology also changed and also game also much faster than the previous. Now, but with the introduced with the synthetic turf, there are a lot of standards and also requirements developed by the International Hockey Federation. So artificial courts. There are 3 types of turfs normally we are using, but the main features is most of the artificial turfs are fabricated using the plastic fibers. This will give the more fast and consistent performance, and also very low maintenance, not like a glass court. So the previous days, the grass court after every match you have to rectify. So you can't play 2-3 matches in a day because the ground will ground was damaged because of the plane because of the plane movements. So therefore, we give a low maintain and also stay unusable in most weather condition. Raining time also you can use the synthetic turf, and also no muddy and no slippery patches. Most of the cases, hockey turf, there are three types of hockey turf. One is the water based. That means when you want to play the hockey, you have to put the water. It will give the more bonds with the fibers, and also it will give the more smooth rolling of the ball. And also sand rest and sand field. So sometimes you sand resting when you are playing, you have some sand. But tropical countries like Sri Lanka, we have preferred to go with the water-based one. And now currently, football already changed into the artificial grass, and also tennis court. Commonly, that a lot of tennis ground also now turn into the artificial grass. That currently is that paddle tennis, one of the new sports, and also very popular. That also now doing with the fiber, plastic fiber turf. Also, rugby also now changing to the artificial turf. Advantages are uniform and ball, durable and long lasting. And definitely game is very fast. But disadvantages are one of the third world cut like Sri Lanka. That's the capital is very high. So and also we can't afford around the regulator because it's very costly. So when we consider the hockey turf, there are three categories. Category 1 field, category the FIH, that means Federation of International Hockey, they have categorized, category. The first category is international tier 1. That is most of the international matches are played. So the FIH standards already in the website, so you can follow. So that is a non-filled wet turf. That means you have to use the water and not the sand one. So the national, the tier 2 field in national competition and training. Category 3 national and local competition, that means provincial match like that, and also training, and also the categories for the schools, schools and clubs and like that. Basically the requirements in the category 1 is the facilities. So you need the facilities for the players, officials, and also the minimum size of the ground. So because depend on the space availability, there are few limitations in the constructions. So, but if you are choosing the category 1, you need the exact values to meet the international requirements. National 2 and also the televised hockey mean that when you are doing the most of the international matches telecast, therefore you need the space for that as well. So that in the category 1, specified how much, what is the distance you need to keep from the boundaries like that. So well defined the FIH guidelines. Category 2, category 3, there are limitations are given, but most of the international matches will play in the category 1 and category 2. As I mentioned that there are 3 types of artificial turfs. One is the border-based hockey turf, sand rest, and sand field hockey. The main difference between these are the combination of turf and infield in there is an artificial hockey system. So water-based hockey pitch. So that is the top of synthetic turf pitch that is water provide fast, safe, and hockey specific terrace. The ideal water-based will be underfoot with stiff early fibers and allow the ball to travel on them. you have a fibers, there are space between the fibers top. So when you are putting the water, it will bond with that, and also that the ball will travel very easily. When you consider the water-based hockey pitches, there are two types of pitches. One is the permeable turf, and second one is the impermeable turf. So water-based, you can see this picture. There is a permeable section. So that's with the turf, shock pad, and the permeable asphalt and aggregate and subbase. So that the water will drainage directly to the water. So there you can see in the every match, you have to put the water. So the new technology turf, there is very less demand for the water. Earlier, most of the turfs are nylon based surfaces. Now is a polythene and sugarcane mix of the production. So that the water demand is very low in nowadays. The new technology turfs. So sand rest hockey pitch, you can see a lot of sand rest pitches in the Middle East countries. A lot of Oman, Dubai, you can see the sand rest hockey pitch, and all that same technology used for the, as I said, in the paddle tennis. So you can see the sand rest same very similar format, but similar technology used in the paddle tennis. You can see the can find in one in Colombo near the police park. That sand field hockey pitches, sand rest field, sand field use sand, but in some extreme cases the sand covers the surface, the barely visible green fibers. This is the international hockey turf in Sri Lanka. We had two turfs. One is a Colombo, one is in Mandalay. So we got an opportunity to give a proposal because earlier that it was damaged because we installed our last, not seasonal one, the previous one, the installed in 2014 or 2015. But with heavy use, it was damaged. But this originally constructed in the 1994. Some 94 and 98, somewhere like the period like that. This is a rectangular area measuring at least you need 101.4 meter and 63 meters. So this is a Colombo one. It's meets the international standard and also water based and permeable turf. That means earlier it was well designed drainage system was introduced to here. So all the drainage system vertically and then moves to the horizontal. And also as per the international requirements, fence were constructed, and also that approximately 80 millimeter thick ABC crushed stone and sand form subbase is approximately 250 millimeters supporting the geotextile layer. The previous one is constructed, we call dynamic base because the turf is constructed on the loose aggregate, top of the loose aggregate layer. But that is the technology we used in 90s and 2000. But after that, we transformed the technology to the static base. So I will explain that. So Mandalay one is constructed 20 years ago, but the size is little bit low. But we extended it to the requirements because previously it was size is less, but we extended one side to meet the required level. So this is a permeable. The previous one is the Mandalay one also. It's a permeable, impermeable base, and also it's a static base previously designed. So this is the current condition means what we received in the 2023. So I will explain through the pictures. So this is the carbon what we so the players are playing on this surface. Lot of injuries. You can't play, but unfortunately, we don't have money to do the rectifications because one of the leading organization has given a quotation, but not the proposal. They give a proposal to construct, rectify this one around 350 million. So it is a very that time in 2022-23, it's very difficult for us to afford. Normally, currently also, it's very difficult to get the allocation for the money for the sports. Was a lot of tours and a lot of the ministry, because I personally work there. So very difficult to allocate the money. So people think it's very easy, but it's very difficult because they have limited funds. However, we came across with the discuss with the professional civil structural engineering, given a lot of knowledge-wise, given good support to the economize hockey turf. So our proposal is around 120 million. So how to rectify this one? So we change full the structure of this one. We change. So because of that, we fortunate to get another facility to the Madali. Earlier we went with this proposal. Because of our proposal is around 120. Actually, we get 160 million, but we end up with 120 million. So because of that, we are fortunate to get another one from the government for the Madali. This I will explain what is the existing hockey turf cross section. So the top layer is the artificial turf, so it's around 20 to 25 millimeter. Then you have a shock pad, because when the players are running on the turf, so shock that shock cell that has to be your foot has to be more stable, and also additional forces not going because of the reactions not going for the legs. So you have a shock pad and also aggregate layer. That's what I say. When you have aggregate layer directly under the shock pad, it is called dynamic layer. Then ABC layer and drainage pipes. Every 5 meter, you have a drainage pipe along the turf. So that pipe is covered with the geotextile, and the water will penetrate to pipes and drain to the side drains. So you can see the another cross section what we have done. So these are the typical section for the Colombo hockey ground. So these are the 5 international standard for the hockey. So these documents are available in the internet as well, and also time to time they are revising these things. So this is the we propose. So what we propose is, now our one is the dynamic one. So if we want to maintain the dynamic one, so there's a lot of concern about the aggregate size, and also that durability, and also the lot of concern about the subplace capacity. So what's our engineer decisions? Our decision was can't be affected for the damage for the ABC layer. So that's why we say we don't need to remove. Earlier proposal all are mentioned to remove the ABC layer, but we have not mentioned that, and we convert this to because we fill another 50 millimeter, 50 to 60 millimeter, because we remove the aggregates layer and we compact the ABC layer. First, we measure the CBR value of that, and again, new layer we strengthen in the top layer, and then we wet with the impermeable asphalt layer top of that. So this is what we propose. First, artificial turf top, then the glue and things, then the shock pad. Currently, we are saying E-layer, more advanced technology, then the asphalt base at the bottom. We have the ABC layer, but we can go for the permeable as well, because then we have to use low density asphalt. We try to go with permeable base asphalt layer, but our suppliers are failed to supply the required density, then we change it again to the permeable type. So these are the key design construction parameters. The preferred round size is 101.4 millimeter and 61 meter. As I say, lower class you have a 97.4 meter and 59. So maximum gradient 1% of holes including compound rates, but we maintained around 4% because will not fail the final test values. Server should not have one unit that exceeds 6 millimeter under 3 meter straight edges or 3 millimeter under 300 millimeter straight edges. These are the key designing criteria. Lighting, there is a special code. So we have page given for the telecast and non-telecast, and also the gold post and everything you have a standard, so you have to follow that. And also the gold post size fence should be 4.5 meter to of gold shooting circle, and minimum 5 meter side fence to the side base. And also for the security and the playing time, you need the 2 gates. It's not only for the hockey, the athletic turf, also you need the 2 entrance, because for the safety wise, and because you can heard a lot of football matches, there's accidents. So therefore they given the standard requirement 2 gates you need to have a get vehicles and also maintenance equipment. So this is a round layout dimension. So this is a that's the standard. That's the minimum standard you can play the hockey. So at least 1.4 meters and 61 meters. Also, you need the sideways. You need a 5 meter to reduce the accidents. So, and also drainage leveling. So this is the more important one. So the maximum gradient in the direction, including the diagonal and combined gradient, shall not exceed 1%. Normally specified in the FIH guideline, longitudinal gradient along the length of the field less than 0.2%, and lateral gradient across the field should be 0.4%. But final leveling will be done with the E layer, but your subbase should be level based on these criteria. What we have done is the earlier previous one. So the existing Colombo one is designed to as per the horizontal drainage system. But because of we have changed, because horizontal drainage system very easy to maintain with the dynamic base. So, but we went with the permanent impermeable base. So we change it to the vertical drainage system. So these are the essential requirements. Removing the current, so for the Colombo one, removing the current which including the shock pad, and also we remove the aggregate base. And as I said, we have done the CBR test for the existing surface, and we removed other, because you can't fill 30-40 millimeter with the ABC. So that's why we remove the existing layer as well and fill the minimum with 50 to 60 millimeter ABC. And test the irrigation system. So you have there are specific criteria given in the code. So if you fill the 1 meter water height, should be penetrate within 25 minutes. Exact value. So it has to be penetrate to the subbase. So the permeability test, we conduct the permeability test as well there, and level is specification according to the FIH, and the whole level must coordinate with the turf supply. So you can see the subbase. So this is the aggregate base what we have removing on time, and also that same time we are going to FSI surface constructed 1 millimeter 300, because we have to fill in the 200 300 millimeter, but we had a subbase. So what we have done, we removed the 30 to 40 millimeter and it aggregates and refill with the 40 to 50 to 60 millimeter ABC again. So asphalt, as I say, so the normal recommendation is going to be the low density asphalt. If you go for the low porous asphalt, it's a density around 2000 to 2500 kilogram per meter. But unfortunately, with our time frame and we couldn't make the trials. So most of the trials are exceeding 3500 like that. So therefore, we decided to go with permanent one. Impermeable one. So that's what we use normal asphalt, what we are laying in the roads, use for this test, and we design the water runoff to the top of the surface. The E layer, earlier we call shock pad. The shock pad is an integral part of the hockey turf system. So not only hockey, if you do the tennis, athletics, especially athletic, you need the E layer to absorb the vibration and shock forces to the players. So many different type of shock pads are available in the market. So what we have used is turf supplies propose E-layer, because the end of the day, the final certification we have to get for the whole product. So we go went with the E-layer which is proposed by the turf supply. So this is a same thing. That's you can see there the right hand side is normal tertiary hockey turf, and left hand side is a tier 2, because tier 2 now fiber side hockey also very popular in the time we have to do it. So okay. can see the VTR subtraction. We did in around within 28 days using the custom plate. Then after the asphalt lake, the minor level changes we can rectify through the E layer. Because E layer normally is specified to use 10 to 15 millimeter, but we have used here 10 to because of our the lumber one we have managed to maintain within 10 millimeter. But Martale, there's a lot of variations, but we used to 15 to 20 millimeter heavily. So this is a E layer, but basically E layer is rubber particles. What they have used is the tire, the crushed tire. So they are using. So we brought from the Germany. So we spread more dollars and here, but they use the rubber. That's material is a rubber. So then they mix in the polyurethane gum and laying on that. So that is the E layer that we have to test. There are specific tests to do. We got the samples. We made some blocks, but unfortunately we couldn't make it in Sri Lanka because we had some financial issues. Otherwise, we to get the international certification. E layer must check with the government standards. So this is a polytan, and the other supply is a polytan. So the polyurethane one and the rubbers, you can see the bags, rubber bags, and also the polytan 8200 is an adhesive to lay the carpets. So you can see after laying the asphalt layer, you have to lay the carpets. So that's a difficult part. So it's any skillful work because you have to stretch the carpet. We can't have any. So they have applied the special tools, and also they use a roller to level the top surface. Three suppliers came from the supplier, and also they were laborers all from the locally to lay the turf. So these are the polytan hockey turf features. The fiber type is a short, densely polyethylene type, and also that material innovation in recent years, polytan has introduced eco-friendly materials such as the sugarcane paste. So I will explain a little bit more in the next slide. But here, Sri Lanka also we use a sugarcane based surface. Actually, this is the first time we use using the France Olympic hockey ground. So elastic base layer, 25 to 35 millimeter layer made from the recycled rubber canvas and the polyurethane binder. So as I say, turf backing to sometimes we are using concrete layers also to infill. Many professional grade polytan hockey turf are unfilled due to their high fitment and density. What we use in the Colombo is a loose lane. Loose lane means only joint is fixed with the glue. If it is a full lane, that means the whole carpet has to be put into the. So, there are polytan have a two plant. One is in Germany, one is in Melbourne. the Melbourne plant is manufacturing full, the fully adhesive, fully blue turf, but German one they are only doing the production the loose-laying turf. So technical features of Sri Lanka hockey turf. So polygon Olympic hockey turf, specifically the polygrass that is they use for the this sugar cane material, high performance with reduced water consumption. So the normal water consumption for turf is 1 to 1.5 millimeter water. So there's treatment based on approximately 80% of bio-based fiber raw material, polyurethane, and sugar cane using green energy production. All the now they are very international. Most of the international firms are very thinking about the sustainability. So now here they use the sugar cane, and also it achieves a climate neutrality at approximately 73 tons of CO2 compared to the conventional turf. As I said previously, we have a nylon based one. When compared to the previous one, is 73 tons of saving of CO2. Technology. Pile height is 11 millimeter and carbon weight 3,000 grams for 20 grams for the square meters. And all the system is climate friendly PU polyurethane backing with multi-back technology. The joint they have a special backing and with the. So these are the equipment. Right corner they have a small spreader that hits in the rubber granules and the polyurethane glove. The blower you can't put the you can't make the dust on that, so you can clean very well. And also this is the rubber granule mixture. Once you mix it from that and put it to the spreader and spread it that one, and some suckers for lay the carpet and also the roller to take that 5 ton roller. Sorry, all the surface. Lighting requirements. So these are the international lighting requirements of the computer. I will thank for the engineer Rasika. So he involved to give try to give a lighting system to the Colombo one also, but fortunately the cost factor but we had done the design work. There are two types, televised and non-televised. So this is a televised hockey turf. So we have a 1,000 to 1,000 class level, but in the non-telecast to be only 200 to 500. So otherwise the video quality will be reduced. This will applicable to most of the sports telecasting. Standards are different because of this. Now the camera technology also moving. So this is the analysis we have done for the Colombo one with the existing one and how to improve that one. Design light for non-Deliva because we don't have a lot of international matches in Colombo, Sri Lanka. So we designed for the non-televised hockey. Recommend level is class 2 because we don't have international matches. We have provincial matches at the national levels. So we propose to give 50 lakhs for the national matches and 200 lakhs for the trade. So this is a Colombo one.
I'm just living my life, no matter what they say, try a million times. My daddy told me keep on living your life, no matter where your days go, baby, don't you let go, let go.
This is a Martale one. You see the water. The cuts are there only. So when you pour the water 1 to 1.5 millimeter. Actually, after laying the ground, we have to get the refined certification. So that also a little bit complicated testing method because we don't have a local or South Asian agent. We have to get down from the Singapore, Malaysia, but unfortunately, government doesn't have the money that time to do the testing. So, this is the Olympic ground. Same ground after this. We constructed the same thing. So, unfortunately, we have a Olympic level ground in Colombo and Martale. So, this is the performance requirement before certifying the ground. That is another area of hockey. So, you need to certify the ground before playing the international matches. So, what the main the key points are hockey ball rebound. So, when the ball is bouncing it, there are so many requirements, national level, international level, and also ball roll speed, consistency between direction to test, and also hockey ball roll deviation. Because you know that horizontal generally it's like an envelope, no? So then the ball can't go curved. Sure, there's a deviation for that, allowable deviation. So it must put the ball speed, it should have maintain the minimum deviation. So ball curvature also one of the major requirements. Shock absorption, surface deformation, shoe surface friction, skin friction, water permeability. So normally 150 millimeter per hour, you need the permeability for the hockey turf. So the permeability is one of the key roles. So this is the additional multi-sport performance requirement for the hockey turf. So the tennis ball rebound, there are so many testing. So you need the international body to get the certification for the for international matches. So this is the product component. So we got the samples because Politan is one of the international and recommended suppliers. They took the samples and gave it to us for the testing. Unfortunately, we couldn't make it. So this testing has to be done. So maybe skip these things. The maintenance, that is the most important one. So it's very difficult to maintain the hockey ground or any kind of athletic field or like that. Because you know, in Sri Lanka, a lot of rain and also that the players and students are using the grounds, so they are using chewing gums. Their shoes are not in the good quality, not like international level. There are a lot of constraints. It's very so we have a daily check-in routine daily. We have done the check-ins weekly. We have given to the government officers to make sure that the test maintenance as per the requirement. So these are the daily maintenance procedure. Because the Colombo one is exposed to a lot of greenery areas, so you have to remove the leaves, things like that. So there are a lot of birds are there, so we have to remove, we have to use the blower to remove that one, the shoe, nails, and you can't use the shoe nail, so you have to use special hockey boots are there. But still, students are using sharp edges, so can't use the sequencer. So these are the weekly maintenance of the environment. Also, it's important to inspect the sprinklers. Without water, you can't use it. It's very important Sprinkler heads are free from any water jets. You have to clean. Plants has to be cleaned every month and clear all the scraps and dispose any material away from drainage system here. Our one is earlier designed for the drainage system. Now we basically using the impermeable one. But drainage system also we have to clean and especially outer side drains. Fencing also we have to check the any loose point was getting accidents. So this is a common use issue we had seen in the recently was the LP formations. Because this is happened with the our climate and also that because of that we had a lot of problems. Finally, we got some solution from the supplier, but they have not give the technology, they only give the product. So they are use some special chemicals and also rub the surface with the high pressure water guns and remove the LP, but we can't stop that, but only we can control this. So I want to give the acknowledgement to the Sri Lanka Hockey Federation President Mr. Vishwanathan and Nobody Court Mr. Monisita and also former Director General Sport Mr. Shamal Fernando. He gave the opportunity to us to join with them and also that because of that we share our professional service with them and also general manager who came to the lay the ground the technical innovation from beginning of the project was a short level and he one of the good sport engineer. And nowadays there are even after the sport engineering, so that's for the lighting, grounds, and we recently we have an inquiry about to the Sugargasa ground also. So we have done the preliminary design requirements. Unfortunately, that also blocked with some issues. So anyway, we are ready to serve Sugargasa ground as well, track as well, to meet the international standard. Thank you very much. Do you have any question? Please.
Thank you, Engineer Shifa Pereira, for delivering a highly informative and insightful session on retrofitting hockey turfs to meet international standards. Your detailed discussion provided immense value to all the participants. And it was indeed a thought-provoking and engaging session on a topic of great relevance in today's sports-related constructions. So we are very grateful to you for this opportunity to collaborate with you in our continued journey toward building a knowledge-based society. So before we start the Q&A session, I would like to remind again that the Google form for attendance is now open and accessible, and it is also available in the YouTube description and the YouTube live chat. You can go ahead and mark your attendance, and please note that the form will only be open for 20 minutes. So if you wish to receive the certificate, please make sure to submit your response within the designated time. If you experience any issues while accessing this form, please inform us by taking a screenshot of the issue and the YouTube webinar page and send it to us via WhatsApp or email. So now we can start with the Q&A session. Participants, if you have any questions, please drop them in the YouTube chat. We will direct your questions to the resource person, and we will give 1 to 2 minutes for you to drop in your questions. We have one question already, sir. Can this flooring arrangement use for cricket court and football pitches?
Definitely football you can use, but cricket you have a circular way, and also that now the cricket is a bit different. So the Australia you have a cricket turf also manufactured outside, and and installing later. So the levels has to be maintained, but this method you can use for the football differently.
Another question, sir. What's the design life of this hockey turf, and can you explain about the maintenance of the
So design life is around for the internet. If you want to play internet method, it's normally defined as 3 years. That turf is given by the manufacturer surface, given manufacturer 3 years. But Sri Lanka, you can use more than 5 to 7 years because we don't have any other option. So we have to use this surface with high maintenance. Maintenance is, as I say, all the algae formation we have to control. That's the point. And also the watering. These new pitches are very the water demand is very less, so you don't need to water every time, but you have to maintain the minimum water level. If you use exceed water, it will improve the algae formation, so spreading that one. So you have to use less water, and also these surfaces are designed for the less water demand. So then the maintenance, there are the turf supply is given different equipments. Those are very expensive. For example, you have to brush the surface and also vacuum that one. There's a special machines. It's around 80 million. Our turf is cost for around 120 million. To do all the construction, but purchasing machine is not relevant. It's better you can maintain and you can keep it for the international requirement, but these machines are very expensive. Most of the machines are manufactured in the German Europe countries, so it's very difficult to purchase with the prices. We like to have one machine at least we can share with the market and the logo, but propose it, but unfortunately the current economic situation we could make it, but we gave the solution. We brought one of hand cleaning machines, and although we are using high pressure water gun, so nowadays India also use same methods to clean the surfaces.
After 7 years,
It will start the they are recommending only 3 for the international.
I think that is all the questions that we have for today. So thank you, Engineer Kipmal, for answering all the questions of the audience and clarifying the doubts. It was a very engaging session. All the participants, thank you for joining our webinar today, and we hope that it was productive and beneficial to you all. And thank you, speaker, once again for joining us. Before we conclude, I have a quick announcement to make on behalf of SDI. So we have our design of high-rise buildings course starting on the 6th of December. And if you are interested in joining this course, you can log on to our social media platforms where we have posted registration links for this course. So you can go ahead and register yourself for this course. And if you have any queries, you can drop a message or email through our WhatsApp and email, and you can also check updates on the LinkedIn and Facebook. So with that, we can conclude today's session. If you are interested in our future webinars, upcoming courses or publications, then please keep an eye on all social media platforms as shown in the screen. And thank you all once again, and we'll see you all at our next webinar. Thank you.